Sprawdzam mikrofon. Działa. So, hello everyone. Welcome back after lunch break. I hope you enjoyed it. For those of you who do not know me, my name is Eva Marchewka. I am working as a test architect in Nokia Krakow. And I am one of the organizers of this really awesome TestDive conference. For the next few hours, I will be the chairman of this stream, Software Testing Methodologies. And I will have the honor of announcing all our speakers. Before we begin, I would like to remind you about our audience interaction tool, Slido, where you can post questions to our performers here. Please remember, if you want to get a reward for the top question, you need to give your full first and last name in order for us to be able to identify you and give you the book at the end of this conference. Second thing is, please do not forget to mute your phones to fully enjoy the presentation here. And now, without any further delay, I would like to announce our first speaker in this stream, Sławomir Zborowski. Sławek is currently coding in Python and C++ for a living. He's a senior software engineer in Nokia Wrocław. Some of you may have already heard Sławek during one of his presentations at TestDive, so you know he's a good speaker, right? If not, we'll give you this unique opportunity to hear Sławek's presentation on testing level hard distributed systems. Please give a big applause to Sławek.
Thank you, Eva. I'm not a good speaker. Okay, so hello everybody. In the first place, I'd like to say thanks for coming here and joining me. As far as I know, we also have some guys watching us on YouTube, so thanks for watching. My name is Sławomir Zborowski, and can you hear me? Okay, I'm going to give a talk about testing distributed applications. But before I start, let me quickly introduce myself to you. So, you almost know everything. I'm working as a senior software engineer at Nokia. I'm based in Wrocław, and when it comes to my interests, well, frankly speaking, it's everything that has anything to do with computers or computer science. And right now, you may think that I have mistaken the rooms because this conference is about testing software, and I just told you that I'm rather writing it. Well, my defense line is that what I have in a job contract, I mean my position, does not entirely reflect what I'm doing. And maybe you are in the same situation. You can hide a lot of things behind a software engineer, and it happens that for the past 2 years I was doing distributed applications. And right now you may say, okay, Sławek, but 2 years is definitely few to become an expert. But you're right. It's too few to be an expert. During those 2 years, I have learned a lot, and I would consider this to be a sin not to share this knowledge. And by the way, when I was doing those applications, the term doing doesn't actually mean that I was only writing the code. I was also involved in preparing test scenarios, preparing test environment, automating everything. So writing code was only a tiny portion of the actual job. Okay, and also I have tried to look for something on Google related to this topic, which is, at least in my opinion, very interesting one. And I have failed. This is not so popular. And this is kind of crazy because it consists of two very famous components. The first one is testing software. Remember how it looked like, I don't know, 10 years ago, a lot of projects, waterfall projects, it was like a brick that was just before the maintenance phase in project. And after a couple of years, we did this transformation, and right now it's like continuous process. We are doing tests on a daily basis, along with writing the code, which is a very good direction, and we can see a lot of benefits. So this is a thing. Now, when we think about applications, we also can see trends like famous cloud shift. So we humans, we generate so much data that applications that run on a single system, they simply can't keep up with it anymore. So we need to distribute the software to handle the load. But when we combine those two trends in testing and software engineering, we have testing distributed apps, and this is something that is a niche. I think we should talk about it, we should think about it, and I guess this conference is like the best place to do so. Okay, so the plan for this presentation is as follows. I'm going to start with letting you know what is the difference between single-node applications and distributed ones. Then I will forward to network partitions and why network partitions are especially important from a testing perspective. Then we will see how we can inject a fault into running system. And finally, we will discuss a couple of other difficulties that are apparent when you're dealing with. Okay, so I was thinking about how to lay this down, how to show you the difference and how to squash everything into one sentence that explains it all. So while thinking about it, how to do this, I was also reading this excellent book by Martin Kleppmann. It's entitled Designing Data-Intensive Applications. And guess what? Right in the middle, I saw a paragraph that was so close to what I was trying to achieve that I simply decided to include it here. And it goes like this. Working with distributed systems is fundamentally different from writing software on a single computer. And the main difference is that there are lots of new and exciting ways for things to go wrong. And I think it's a perfect comparison. We all know that the software fails. When we distribute the software, it is going to fail more frequently. I'm going to repeat this over and over. Okay, how does it look in practice? A story from my life. When I started doing distributed apps, when I was going to the office, I was almost certain that something will be broken this day. So each time I was, thinking, okay, maybe today it will be internal authentication, maybe internal DNS services will not work. So to prove it, I decided to write that extracted all of the from my mailbox. Okay, so is it better now? Okay, so this puts me in quite uncomfortable solution because I don't want to have two hands busy. However, I'll try to act natural. Okay, so basically I wrote a script that extracted all of the emails from my mailbox, and it left only those that had keywords like unplanned outage, network fluctuations, stuff like this, and then put it on calendar, and this is what I got. So the blue item represents a business day that when something was broken. So as you can see, in months like November, we had only 4 business days when everything was okay. So it's like crazy. The lesson from this is that failure in distributed environment is something that is a commonplace. Almost all of the time, something is broken somewhere. So that's frustrating. And I was so frustrated, I wanted to release the pressure. So I even did this hardware project. It's a real thing. If you go to my desk, you will see this. I call it a wheel of misfortune. So each time something's broken, I can approach it and roll it and see what it is, like no root to host or disk is not attached or some network disruptions and so on. And there is only one field that is left blank, and it is very unlikely that you'll hit it. Okay, and this brings us to the difference between failures, between single-node applications and distributed ones. Because failures in those systems are not the same, and we can see differences. And to show you the difference, let us have a contrived example. Imagine you have an application that runs on a computer like this. So we have CPU, memory, and disk, and it requires a disk. Like this, right? You have a disk, and the application will not run without a disk. Now the question is, what will happen when the disk fails? Any ideas? What the application will do? Yeah, the application will also fail. It will refuse to execute. Is it acceptable? Kind of, right? Because if you have an application and your application requires this, and you don't have this because it has failed, then it's quite acceptable to tell to the user that, sorry, but you need to replace something. How does it look in distributed system? consider we have simple application with 6 nodes and 2 of them have failed. Now, the question is, in this scenario, can we say to the user that, sorry, but we refuse to execute because there is some failure? Not anymore, unfortunately. So the problem here is that the application still has some resources on other nodes. So it can simply redistribute those parts of the software, so it will still continue, maybe with some little disruption. Now, the case is that this thing has a name. We call it a partial failure. It is very important to know this. A partial failure is something that is, I like to give this comparison to physics. So if we talk about classical physics, everything is fixed. You can calculate everything, and it is easy to reason about classical physics. When we think about quantum physics, it is not so easy anymore. So you can have states that are both 0 and 1, and it is the same with distributed apps. So it's very unlikely that you will observe a fatal failure and everything will stop working, but also it is unlikely that every part of your system will work flawlessly. So you are going to be somewhere in between. And if you are lucky, you will be closer to the right side, so almost everything will function correctly. And it happens that it is a commonplace, because consider this example with the disk again. Question: in your opinion, how often such a piece of hardware will fail? Once per how many years? 10? Lower? Higher? 3, 4, yes. 3 to 4 years. Now it's kind of good result, but then if you have a data center and you have 10,000 computers and 2 disks in each, then you will need to replace a couple of them on a daily basis. And this is the problem, that actually this is a common place and your applications are running in this data center, so your applications need to be robust against such a failures. You need to do this on a software level because hardware will not solve this problem for you. And for this, I like another analogy, this time to biology. Let's talk about brain. It consists of millions of neurons, right? Now, what happens when hundreds of them die? Do we die with those neurons? Not really. Otherwise, just one drink and you're done, you're dead. And basically, it is actually quite opposite, quite the other way around. So we are having fun most of the time when we are killing those neurons. And our applications, when we do them and they are distributed, they also should be robust to partial failures like this. And this is why testing those applications is also very hard. Like, you can observe network partitions, you can have unexpected network latencies, and you need to test this all. You can also have things like synchronization issues. There might be a problem with the hardware, and also some problems with clocks. And eventually, if you have race conditions, then you're going to see a lot of them when the application is distributed. Another question to you: how many particles do we have in observable universe? Any ideas? It's many, right? Many is a good answer. And also it is a good answer for the question, how many failure scenarios do we have and edge cases when the application is distributed? Okay, now let's see what is a network partition. This is a thing that is especially important from the testing perspective, and I will let you know why. But before I do this, let me show what a network partition is. Do you know what a network partition is? Who knows? Show your hands, please. Okay, excellent. So it's not rocket science. So imagine a system that has a couple of nodes and those are connected in some way. And then a network partition is simply something that breaks the link between any of components. This break can be one-sided, like you can send some messages, but you cannot receive anything from others, or it can be two-sided, so you cannot send or receive. Also, this can be, it is possible that it will not be only one failure at once. You can have multiple failures at once. And the funny version of a network partition is when your network is split in two even halves, then you can observe some weird behaviors in distributed databases, for instance, split brain. This is how we call it. And also you can have fatal failures. And fatal failures are when everything is disconnected from the network. But why this is so important? Well, what application can tell when it sends a message to other application or other part of the application and it didn't receive any response in time? What it can tell about it? Can it distinguish between hardware failure or a software failure? Not really. And this is the reason why network partitions are very interesting thing when we thinking about testing distributed apps. Because from the node perspective, if we don't receive a message in time, it can be either that there is some network problem, so the message hasn't arrived to other peer, or maybe the reply was not delivered to us. This is a possibility. Other possibility is that there is some kind of a hardware failure, like a network card malfunction or something. Also, we might experience software failure. So we are sending some message to the guy, but the guy has crashed, and we are not having any responses from him. Also, interesting edge case is that we, or the guy we are communicating with, are overloaded. So the network is fine, it is okay, but the message goes to the operating system, it goes to the buffer, and application is overloaded, or maybe we have, I don't know, long garbage collection cycle if you are using managed languages. And the reply comes, but it is too late, and the whole operation times out. And the thing here is that node cannot tell anything about it. It can only tell that the response didn't come in time. And this is why we can use it to test our applications. Now let's see how we can inject faults into running systems. So how many of you know this distributed database called etcd? Anyone heard of it? Okay, I see one hand, I see. Great. So this is a famous distributed key to value store. It has an interesting fact that more than 50% of the code is actually dedicated for testing. So it has very good quality. So I was curious how they approach testing it. And it is quite simple. It's not rocket science. Again, so you have some kind of orchestrator that has two interfaces. The first one is used to use the database. It can read from database and write to database. And the second is to control particular nodes. So it can control that particular node in the cluster will be switched off. Possible test scenario is like this. Let's stress the cluster, and then let's kill this node. After waiting for a minute, let's see whether the cluster rehealed itself and everything is fine. But deploying virtual machines in AWS, if you're allowed to, or on premises, is like a nightmare if you're not experienced. So there is a better way. Maybe this technology will be more popular among you. How many of you know Docker? Okay, this is what I expected. It's more popular. So for those who don't know, a Docker is providing something like a virtual machines. We call this container. And it's basically isolated process that has its own networking interface. So if you are setting up multiple containers and you're able to do this using Docker Compose, so just one command and you can spawn 10 containers. And then you can play around with the network. And of course, playing around with the network on a single machine is not that easy. You need to use tools like IP tables and TC and so on. And this is why we have another tool. It's called Blockade. And using Blockade, we can, test different scenarios by injecting a fault into running distributed application. To show you how it looks like, let's consider this very simple and contrived example because we don't have time for anything bigger. We have a backend that will accept requests, and the request is to download a file, so it's a simple task. It goes then to the distributed queue. The implementation, in my case, is just a Redis database. And finally, we have this worker, which is responsible for downloading. So it's quite simple, right? It gets the tasks from distributed queue. So now let's have a demo. Is it working? Okay, so at the top I have output from the download worker. And at the bottom I have my console, so I don't see what I'm typing, but this is a helper script that allows me to download a file that is that big, right? So when I hit enter, I can see that the request number 1 is exactly this file. And to show you that it is not a fake, if I put, sorry. If I put another file that is bigger, you can observe that the download time is almost 1 second, right? But how can you test anything if it is so fast? Let's make it, I will just make some optimization. Let's make whole network flaky, so it will simply drop packets, duplicate packets, it will become slow and so on. And it takes a couple of seconds because magic happens under the bonnet. And then if I try to download a file, you can see it was quite quick, but look how slow it is. And now I can do all of the things that I want to. So network partitioning, playing with the network, introducing some latencies and so on. So with a couple of commands, you are able to test distributed app on your own system, just like this. And because it is going to take a lot of time, let's bring it back to normal. Again, it will take a couple of seconds. And if we will be lucky, we will see that the request is completed. But it can take some time. Okay, here we can see that the file was downloaded, but instead of a second, it was almost 1 minute. And it is not always like this. When I was practicing this presentation, I was running this over and over, and I have found problems like this. So I was ordering it to download a file that was 256 megabytes, but it reported success after 400 seconds, and it downloaded only 82 megabytes. And it was successful from its perspective. So as you can see, we can find problems with this tool, and a lot of problems can be in even simple stacks. Okay, and the last thing that I like to discuss is the difficulties that we have when working with distributed applications. And it basically boils down to a famous comparison between pet and cattle. You know this comparison? So basically, when you are working with single nodes, you can remember the IP address, you name this, you can configure everything by hand, and it's so nice, right? But then when you distribute the software, you need to go to some cloud, you need to use virtual machines, and then you will not remember all of the IP addresses. So you need to introduce numbers, and then machines can, go, and new machines can appear just like this in virtualized environments. So it is much harder, and everything boils to this. So for instance, when we want to debug something or replicate some bug, then what we need to do in distributed virtualized environment? We need to spot the place where we have a failure. Then we need to find an instance. And finally, when we want to SSH in, you can see a message like this. And I'm not joking. I have seen numerous times things like this. How it is possible that my virtual machine now has IP address all zeros, and now I cannot access this machine at all? I have done nothing, but some guy from IT department did something, and now I can't access my machine, which maybe had some logs or something. So when it comes to logging, we also can't SSH into each machine to gather the logs, right? It's not possible. You need to use some centralized solution, like we are using Elasticsearch with Logstash and Kibana. And basically, if you get used to it, you can be quite fluent, but still you need to deploy additional machines, which basically brings other problems. Also, when it comes to performance, if you want to test performance, look for bottlenecks, then single machine is fine, because you use commands like iotop, htop, and you're done. It's quite, let's say, easy to find bottlenecks. In distributed systems, it's not so easy. You need to deploy other centralized solutions and so on. So basically, it all boils down that you have this cattle and you need to manage it. Okay, so again, I'm going to repeat this, that we have many more ways for software to fail in distributed environment when the application is distributed. And this is why it's hard to test it, because we need to think about all of the possible scenarios, all edge cases, and it's unimaginable what can happen in the real world. It's hard because of this. Also, asynchrony is not helping, because if order of events can depend, the outcome can depend on the order of events, then it's tricky. And also, when we are fighting in distributed environment, then basically we need to solve other problems as well. So once again, the number of edge cases and failure scenarios is so big that it's very hard to test everything, but still we want to have as broad coverage as possible. So testing distributed apps is much, much harder than testing single node applications, because we need to think about more scenarios. But with appropriate tooling, you can do this. This is everything that I prepared for you. Thank you.
Yes, this was Sławek Zborowski. Let's see if we have any good questions from Slido. Okay. I'm not good at jumping with my heels, so I need to go. Okay, so here's the question. Are you doing something to prevent environment issues, failures, or you are focused on software to mitigate this risk and handle environment issues?
Well, I have one remark when it comes to this, and it is to prevent having state. So if you're stateless, then you can deploy everything once again without a problem. If there is a state in your environment, then it's much harder, because if you want to migrate from faulty environment to the functioning one, then you need also to get the state from one place and put it in another. So having stateless services is the solution that we try to take. Basically, I hopefully this addressed the question.
Can you hear me now? Okay. So since we have only one question, is there another question from the audience? Is there anyone Does anyone want to ask something? Raise your hand, don't be shy.
Hey, my name is Piotr. Do you performing any tests to simulate the failures, something like Netflix doing Chaos Monkey, Gorilla?
Unfortunately not, but we are going to eventually. I mean, this is an excellent way of thinking, and we should all stop thinking that production is something precious that we should care of. We should treat production as something that we need to try to destroy. Like drinking alcohol, you can destroy your brain. So we should have Chaos Monkeys. Unfortunately, we are not there yet.
Okay. You work in Docker?
Sorry?
You working on Docker? Like
yes, we are working with Docker, Docker Compose, Docker Swarm. Basically, we are one step. In one step, perhaps we will go to Kubernetes.
So Docker have some tools for like Chaos Monkey?
Yes, yes, I know, but still we are not there yet. Our software is not prepared for this.
Thanks.
Any more questions? Do we have time?
Okay, so let's give a big applause to Sławek for this great presentation. And now it's time for 15 minutes break, so you can leave for until 1:30.
Nie, mnie się bardzo podobało.
Ale przede wszystkim to, co zrobiliśmy, to za krótka jest ta przerwa była obiadowa. Dużo ludzi nie zdążyło w ogóle.
Ale powiem ci, jak dla mnie świetna. Mnie się bardzo podobało.
Dzięki.
I wiesz,
przynajmniej jedną ścianą parcie.
Nie, powiem tak, to było nagrywane, więc no będziesz na kamerze. Ja będę zachęcać ludzi, żeby to
Nie, tylko nie to.
Raz.
Te kółko przywiózł, to nie pokazał.
Ale podobało mi się to, wiesz, z dyskiem i...
No, w sensie, no to tak sobie pomyślałem, bo leżał dysk. Kurde, jak to będzie zamontować, żeby pokazać coś.
No ja będę testował, on nie jest
To jest, wiesz,
technik nie jest pewien. Nie wiem, co zrobić, zapytam się go. I have a question. We have this mic report, but as you've probably witnessed,
I'm okay with the mic. No problem.
you're okay with the mic, okay? Because well, the technician gave me another one, but he's not sure if it's working.
No problem.
Okay,
I'll
then
be okay with you.
Zmienione. Sorry.
Welcome back after a short break. Please make yourself comfortable. Do not forget to mute your phones to fully enjoy the presentation. Our next guest here is Alexander Iristik. Alexander is a test consultant. He's working currently leading a team of over 40 people from 7 different cities, from 4 different countries, which is pretty impressive, and cooperating with clients from really different industries like telecommunication, storage, and gaming. He's a very experienced tester. He's been working as a test engineer, test automation engineer, test manager, and he has a great passion for bug hunting and improving quality assurance processes and procedures. Please welcome Alexander with his presentation, Agile Transformation Guide for Test Engineers. Let's give him a big applause.
Thank you, Eva. Hope you can all hear me well. If you want me to go louder, just scream. So just before we start, Comtrade had his own test conference in Dublin some 2 weeks ago, and we had one of your own Nokia guy telling the great story about what you guys are working on. If I remember correctly, his name was Ruben, so if anybody knows him, just say him hi for me. So this is me trying to return a favor here at your test conference, and who knows, maybe this is the beginning of the beautiful friendship. We'll see. Thank you all for choosing Stream 2. You made a right choice. However, we do have a problem. We do have a performance issue. As you can see from my gray hair, I have been in business for a long time, and I have been testing developers, and it's a love and hate situation, and I have a lot of stories to tell, and 30 minutes will not be enough. So we have a problem there, performance issue, I like to say. However, if you stick with me until the end, I promise I will deliver a fix for that issue, and who knows, maybe even a bonus at the end. So stick around. This presentation will have 3 parts. First will be about individual performance of test engineers in Scrum team. Then we'll talk about team, test guild. And third part will be about 2 short case studies, just sharing some good practices. So let's see. Like I said, first thing is about test engineer in Scrum team, actually surviving guide for test engineer. Let's go through the sessions in Scrum team in Agile framework and try to learn some good practices to make most of them. First one is grooming session or refinement session. You might see that very often test engineers are not even invited to this session, and that's a big mistake. It's actually the very good reason why they need to be there, because that's where testing starts. It's not just that they need to ask questions about new feature, new user story that they will need to test after this, but they need to learn how it's going to be developed. They need to discuss with developers and Scrum Master and Product Owner what's the good testing approach. They need to think about how they're going to test that, but not even that. On grooming session, new idea is just words on a paper, so it's not really expensive to fix something. You're just rewriting it in a user story. Once the code is developed, pushed to production, it gets 100 to 150 times more expensive to fix. So even if QA people are on grooming session or refinement, they often forgot to test the new idea. And it's very important for them to do that, because test engineer who is testing on system integration level, on end-to-end scenario, he knows how the whole system is working, while developer who is going to work only on one component doesn't have that overview of the whole system. So it might very easily happen that tester can see at the very beginning why something will not work, why one little component, one little feature will not work well in the whole system, while developer who is focusing only on that one component will miss that. So it's very important not just to ask questions about a new feature to be able to test it later. It's very important to start testing on a grooming session. So push your way into that session if you're not invited and start testing on grooming session. Second important session is planning session. This is where you estimate user stories and you decide what will go into the next sprint. What's very helpful is to tag all user stories that are suitable for testing. Tag them with manual QA or auto QA, depending on either going to be tested manual or automation or both. Just tag them so you will know later that you are expected to test them. Even better, open subtasks, technical subtasks for QA, technical subtask for manual, technical subtask for automation. Why? At the end of the sprint, everyone will be pushing you to close as many user stories as you can. However, if you have open technical subtasks for QA, you will not be able to close user story if it has open technical subtasks. So that will help you to fight for not closing the user story where testing is not finished. So it's very helpful to have those. And if you assign those technical subtasks to the testers, so you will know who is doing what, you will know exactly, for example, in Jira, it's easy to see if there is QA work left to be done on some user story when you're trying to decide whether its user story is for closing or not at the end of the sprint. Now, the sprint, everybody's pushing now that development and testing should be done in parallel. It's very difficult, of course, and in this transition from waterfall to agile framework, testing was always at the end. However, you need to push and to ask from development. For example, if you're testing front end, you need to ask for wireframes, for all the buttons, all the locators, all the links that will be developed for in that new user story. So you can prepare your scripts even before the feature is developed. That way, you can keep pace with development. You don't need development to be finished so that you can start doing test automation. You can prepare the scripts, all the steps before, all the steps after that little feature that is being developed. Even better, if you manage to agree with your developers to always provide ID locator for all the objects that you're going to use in your scripts, you will even know in advance. You can prepare your scripts even in advance. If you need to click on login button that you know will have an ID login _ button, you can almost create the whole script. Similar on a service level, if you're testing API, REST, SOAP services, you can ask developers for the examples of payload, requests and response. So because you need that in your test automation scripts, again, you can prepare all the steps before and after the new feature. So you don't actually need to wait for development to be finished on those user stories. However, you need to ask them to provide that to you. It doesn't work any other way. Also, story bugs. You can very easily get confused about what bugs are open for some user story. Can you close user story? Are there any open bugs? I don't know. You are possibly using different defect tracking tools, but in Jira, if you are opening bugs as a technical bugs under the user story, it's an easy way to track if there's anything open under that user story. And at the end of the sprint, team can decide open bugs. Are they too important so user story cannot be closed and move that user story into next sprint? Or bugs are not so important, you can move them as a standalone bugs to the backlog and you can fix them some later point in time. So it's very good practice to open bugs under the user story, because that way you will always know how much work is left under the user story. Morning stand-ups. We already, I think Rex already mentioned that. It's very easy to lose precious time on the morning stand-ups. There are only 3 questions you need to answer on morning stand-ups. What did you do yesterday? What you're planning to do today? Do you have any problems? It's okay to have questions, but only people who are involved in that communication should left after the morning scrum. Everybody else are free to go. So don't waste time. Always be prepared when you come to the scrum. Have your user story ID, have your bug ID that you just submitted, or user story ID that you are testing prepared when you come to the morning scrum. Because I have seen people saying, okay, I'm working on that user story about new user doing this and that, and then Scrum Master is searching on the Scrum board for that user story. Everybody else is waiting. Is it this one? No. Is that one? No. So don't be that guy. Be prepared. Have your IDs ready for that morning stand-ups. Only 3 answers you need to tell there. What did you do yesterday? What planning to do today? And do you have any blockers? Retrospective is maybe most important meeting in Agile framework and often neglected, not used. People start thinking about their input for retrospective when they see a reminder for the retrospective meeting 15 minutes before it starts. Of course, it's too late then. My advice is to have a piece of paper, notebook on your desk, and write down anytime you see something bad, anytime you see something good. Don't use that retrospective meeting only for complaining. Remember to tell the people, remember to mention the good things, good practices, people who helped you. Don't only complain. But most important, use the whole sprint, whole 2 weeks or 3 weeks, whatever you're using as a length for your sprint, use the whole time for input. Remember everything, so when the sprint comes, you will have some input, some valuable input to share with your team. Don't just be passive and listen to others, because this is the unique opportunity to improve the work of your team. You know, soft skills are so common things, so I wouldn't waste too much time about this, but maybe just to share some good practices on communications. The problem with communication in Agile framework, the whole framework was introduced to improve the communication between team members like development, testers, Scrum Masters, business owners, business analysts. But ironically, for test engineers, it broke down communication because in Waterfall, testers had their own team. They worked together with other testers, and they were happy. Now in Scrum team, they are outnumbered. It's only 1 or 2 testers, and who knows how many developers. You have Scrum Master, you have business owner, and test engineers have lost their team. So it's very important to talk with developers. You know, they are also good guys. They are not bad. Or as I like to say to my people, keep your friends close, but keep your developers closer. So always remember, when there is a new feature, new user story being developed, go and talk to developer, ask him for the input. Is there some other area that needs to be tested? When you are verifying a bug, go ask developer, is there some other area that might be broken because of that bug? Because it doesn't happen very often that developer will just fix one bug and not break anything else. So ask what else could be broken when you're verifying a bug. So in short, talk to your developers. Also, today, everybody is pushing for test automation. You know, everybody's talking about test automation. Manual testing is obsolete. Nobody needs that anymore. However, if we've only focused on test automation, only doing happy paths, proving that code is working, who is then doing the testing? I've seen sprints are being done, 1, 2, 3 sprints. Automation is even keeping pace with development, but there are no bugs. Nobody is submitting bugs anymore. So don't forget, you are test engineers, you are here to find bugs. You will improve quality only by submitting bugs, by preventing bugs to come to the customers. And just doing test automation, just coding, happy path, you will not do that. Best case, you will have good regression test suits who will make sure that nothing that worked before is broken. But you will not find really good bugs. So remember, it's your job to find bugs. Don't focus only on test automation. Also on reporting, if you are using too much details, no one will have time to read your reports because no one has enough time. And that's one thing that I really wish that someone told me when I was starting with this business. You will never have enough time to test everything. So use the time you have very wisely. Also, if you put too little information in your test reports, people will come to ask you for what they need. So it's very important to find the right measure. And how do you do that? You don't need to invent the hot water. You just go and talk to the people who will read your test report. Ask what's important for them. Someone will focus on number of bugs. I don't recommend that. But everybody, like, you know, Rex mentioned that return of investment. Everybody likes to see a return of investment from test automation, for example. So it's a good idea just to measure how much time is saved with test automation, how much time you need for manual execution, how much time you need to execute the same scenario with test automation, times number of scripts. That's easy win. It's not really 100% good, but it's easy win for you. Or someone else would like to see in test report the amount of time that is saved when doing continuous integration, how fast can you deploy something from development phase to production development. But important thing is to ask people who are reading your reports, whether it's management, whether it's your team, ask them what they want to see in your test report. Also, this is, once you're in Scrum team, this is a team game. There will be, you will not be a successful test engineer if your developers are failing to deploy or deploying too late with many bugs because you are not helping them with your test automation scripts, or your management is failing to plan for the project because your test reports are not showing them where the risk is. So keep that in mind. You are here to help them. So this is a team game. You're only part of the team, and make sure that you're helping them. So everybody knows how to submit bugs, but let's try to see some good practices to lose as little time as possible when submitting bugs. Now, okay, first thing, make sure that things is a bug, that you know what you're doing. But second most important thing, maybe hands in the air if you ever find a bug and you were not able to reproduce the bug. So you find something, it's a very common thing. Yeah, of course. So first thing to do, save a screenshot and save logs. Because you know, when you are unable to reproduce one problem and you go to developer and you tell him, I think there is a bug here, but I'm unable to reproduce. You think he will take a look at it? No. So save and have a proof that something is not working. At least that it was not working in one point in time. It's much easier after that to negotiate with the developer. So bug title is most often read part of the bug. Usually people are just doing searches, going through the titles, so make sure that your title is very correct and it describes what's happened with that feature, with that bug. So it's good practice to use keywords like UI, DB for database, API, REST, SOAP, but it's important that whole team knows what are the keywords. And also good practice that you agree that use all upper cases or all lower cases. So don't just have 4 different versions of GUI, GUI, all upper cases letter. So just agree on one way. It's a very common thing when you're beginning testing, especially on a front end. There is a new page and you find 5 different problems on that page. And it's tempting to open you don't have enough time, of course, you open just one bug with those 5 problems. What usually happens is that developer will fix first 3 problems, he'll ask something about the 4th problem, and he'll completely ignore the 5th problem. So don't do that. It's really a golden rule, 1 problem, 1 bug, and you'll save yourself a lot of problems there. It will not happen that only test engineers will submit bugs. Either new bugs will come from support submitted by customers, or business owners, or project managers, or some other guy who are not very efficient in testing. So it will be very difficult for the people to try to verify or even try to reproduce those bugs. Very useful thing is to use a template. When you try to open new bug, have a template ready, like you need to enter environment, often forgotten when somebody is submitting a bug. You need to enter test steps. I don't know in your company, but in my company, developer never writes a test steps. They just attach a log file or something else, so it's impossible to reproduce that bug. So make sure there are test steps in that description. Make sure there is actual and expected behavior so you can pinpoint the bug. So all these things put in template, and make sure that whenever someone tries to submit something, there is a template waiting for him, so nothing will be forgotten when you're submitting a bug. And of course, don't just forget about your bugs, especially if they are critical major blocker. Revisit them and see what's going on with them. If they are not being fixed, go to developer, talk to him, and ask if he needs some help with the reproduction, or what usually happens is developer is on vacation or on sick leave, and he's being default assignee in Jira. So you need to do something about either reassign the bug or something else. Now about the team. Even if there is no test team anymore, you can create your own test team if there are more Scrum teams working on the project. So you can improve knowledge sharing and supporting between testers. So if you have many Scrum teams, it's a very good idea to put all those testers working on one project, sharing the same technology, having the similar problems, put them together, join them together as one team, and lead them, organize weekly meetings just to be able to share knowledge. First thing to do, of course, is to make a contact list. This is often forgotten, very easy win, but often forgotten, because when you want to share some information, have some mailing list prepared, have some page with contact information for all developers. Very good practice for knowledge sharing for the newcomers. If you are not using it, probably what you're doing when someone new comes to the team, there is a mentor who is working with him day by day, showing him tools and stuff, documentation and everything. However, if you record all those meetings, either through Skype, video, or link, whatever you're using, and gather all the documentation and organize that documentation in folders, in days' work. Folder 1, for example, will have how to set environment, what documentation you need to read. Day 2, for example, folder will have training that you need to finish, tools that you need to install, and so on and so on. That way, the newcomer will be able to learn to prepare for the projects on his own. You will not need a mentor time for him. So it's a very good practice to gather all the information, documentation, and trainings, put them into folder, so you have everything prepared for the new people coming to your team. And this is easily scalable because you are not using people who are working on the team anymore. Everything is prepared for them, so people can prepare for the new project on their own. They are not wasting anyone's time. Of course, you will need to be there for support for if they have some questions, and of course, you need to check with them if you need to update some documents or some links. You will have, in a book that is following this, you will have some links to the online trainings, for example, for Java or JavaScript. You will not learn JavaScript or Java from them, but it will help you for the newcomers to refresh the memory of some tools, some languages. And QA Guild in your company, so this is some level up, how to get together the whole test community. It's very good to have at least monthly meetings where you sit down and you discuss the project's expectations, problems that you have, challenges. But you know that regular meetings, work reports, they become boring very, very easily, and people will be just quiet. So I do recommend that from time to time you have lean coffee type of meeting. There'll be no agenda there, so people will just say their own topic, and you will vote for each topic. And some good ideas would come from that kind of meeting. So don't always just have strict agenda. Just play around. So that's how you'll get really good ideas for process improvement. Also, good idea is to have on company level to have a page, at least a place on Wiki or Confluence, where you will have a top overview of all the projects, of the quality on all the projects. Like, do you have enough team members? Do you have enough resources? Are you happy with the tools, test approach? So someone from the outside, either from management or from outside the test quality, can easily see where the problems are. And they will not bother you with those questions. And of course, it helps, even if you're talking about the project or the whole QA guild, it helps to invest in common libraries. I'm talking about test automation here, of course. It helps if you have a team that will prepare common libraries, common functions, methods that will be reused by the teams, by the separate teams on the projects. Either it's Selenium or Protractor or JavaScript or Java. Don't reinvent it again and again in separate teams. Have one team, one technical team that will prepare all what you need on your separate test team. That I think also Rex mentioned that. So you can make life easier for the people working in the teams. They don't need to reinvent the wheel each time they're starting a new project. Of course, just to go back, don't forget about manual testers. People often ask me what I think about manual testing. Is it still there? Do we need manual testing? My opinion is that until we have some kind of artificial intelligence in testing, you will always need manual exploratory testing. Now, we are losing some time, and very quick about 2 case studies. Be smart, protect yourself. Just to put you some background, this is one of our latest projects that we have in Dublin. Company was doing front end in AngularJS. That's a framework built by Google for a front end, and they were deciding which test automation framework to use for that front end. So we were consultants there, and it was pushed from development actually to use Protractor. That's test automation framework built specifically for AngularJS. Why it was good? Why it was good decision? Because Protractor is synchronized with AngularJS. So all those sleep, wait stuff that you have in Selenium, Java, you weren't needed them anymore. However, this was not accepted good from the most of the test engineers on that project. They actually left the company because of that. But I'm not propagating any tool. The main idea of choosing the right tool was that this choice actually brought developers and testers closer together. Why? In the beginning of the project, there is more development, less testing. At the end of the project, everything is developed. Less development work, more testing work. However, there was not enough testing because they didn't have enough to work on the beginning, so there isn't enough testers anymore. And the project managers usually fix that problem by adding more and more people to the project at the end, expecting them to do anything without knowing the technology, without knowing the product. However, on this project, we have developers helping testers by doing coding of test automation scripts. Why that was possible? Only because Protractor is using JavaScript, and developers already knew JavaScript because they were developing front end by AngularJS. If some other tool, some other language was chosen, that could not happen. So make sure that when you're choosing test automation tool, test automation framework, make sure that that choice will bring your developers and testers closer together, because you want them to work together. Also, I already said you will never have enough time for everything. Pareto principle was already mentioned before. 20% of your code will have 80% of the bugs. So you'll need to find where you need to focus on those 20%. You need to think how to focus there, and you will have more explanation about that in a book that I will show you later. But don't tell this to your management, because they will think that you are not testing the rest 80%. So I'm not saying that, I'm only saying that you need to find where to focus on which 20% of the code. Second case study is with a big travel, in a travel industry, where the company was doing a product for the Lufthansa. Now, it's not only that you're buying a ticket from place A to place B, but you also are getting hotel recommendations, holiday recommendations, rent-a-car offering, and everything. So in this project, we had some 70 different third-party providers. Some of them are unstable, not up and running all the time. Some of them, like Amadeus, are taking too much time to return the flights offering. Or if you wanted to close the deal and to buy the tickets, it was sometimes even expensive to use that API from the banks, from the payment processor to finalize the purchase. So we needed some solutions, and it was almost impossible to do test automation there, because the best case, some parts of the scenario could be automated, and on some parts you need manual execution to choose something, because you can never assure that there will be a flight on that certain date, or there will be free seats on that certain date, or in that class, business or economy. So we needed some way to make sure that environment is stable for our scripts. So mocking is working, but on unit level, component level at best. And we needed something on end-to-end system integration level. So after looking for some solutions, they were too expensive for us, we decided at the end to develop our own simulator. And that simulator was working on in the background as a service. And it was available for all the teams that could use it for all different providers. Even same providers had different instances, so it could use by different teams and return some different responses on requests. All what we needed were from the test engineers to tell us which responses they are expecting in their scripts. So we filled those responses in a simulator, and he was listening to their test cases, coming with requests to give them the right responses. We had also possibility to play back when we wanted to return some response, but also transparency mode when we just reroute requests to the real third-party provider. Of course, we needed to prove that test case and the feature is working, but once with the real provider, but once that is proved, we just switched simulator on, and we didn't have any more problems with the third-party provider. So even developers were happy, because they too had the problems with developing stuff for the providers that were unstable. Now they didn't need provider anymore. So the point of this story, if you have environment problems, don't just learn to live with them. Try some way, build some tool to overcome them. This is the, and this simulator will soon be open source free on GitHub, and we'll have a presentation on next UK Stars in March 2018 that will use this simulator, so you're all invited, of course. Now, we have very little time. Yes, okay, so this will be everything I prepared. Very good timing. So I promised fix for that performance issue. Of course, the story is much larger. There are many other stories to tell, and this conference is a second conference that will have access to the book that is following this presentation. You will have a link here. There's a link for download. Book is free, so feel free to download and to read it. But also, first part of the book is this technical, boring stuff about work. But second part that I'm very proud of is my first short science fiction story about testing artificial intelligence and a bug called Random Stories. So, in short, there are links here for Comtrade Digital Services where I'm working, my email and my LinkedIn profile. Please get in touch, and link for download. I hope you enjoyed the listening, and I hope you will enjoy the reading, and please comment at least on that science fiction story, because I'm very interested to hear what people think about it. Thank you all for listening.
Okay, that was Alexander Ristik, and now we have questions from audience. There's quite a few. So the first question is, what are your tips to make communication effective in case of Scrum team members being in different locations?
Okay, that's a very good one and very common one. We all have outsource testing, either in India or China or wherever. So first thing is video link helps. It really helps if you have a video link on your morning stand-ups or your planning sessions, so you are able to see the people that you are talking to. On Comtrade, we love to do team buildings, but of course that's very difficult if you have different locations. But if there's any way to do a team building, at least of the people who are on close locations, do them. ask your management to do support for that team buildings. But video links are easy win for communication.
Okay, I think we have time for one more. So the next question is, should test engineers stick to testing role while working in a Scrum project, or should he take other tasks, development, requirements, documentation, etc., as well, if his time allows it?
Very good question, and I do agree here with the thing that Rex mentioned this morning. I'm supporting outsourcing testing to developers, in meaning that they could write test automation code, but I'm not even advocating that they should propose how to test something. Test scenarios should be creation of test scenarios, and test approach should be done by test engineers. Testers doing some other work, I'm not a big fan of that, because I should encourage testing documentation, but doing other work, I shouldn't suggest that, because it's whole mind approach, mind thinking that trying how to break stuff, that's what we are doing good. So I would stick to testing.
Okay. There is time for one more. So the last question, is Agile a cure for every project? What are our thoughts about waterfall?
Definitely not. Definitely not. It really depends on your customer, and the expectations from your team and from your project. So, for example, this project that I mentioned for Lufthansa, the company is doing in waterfall system through the customer. But inside the company, we are doing Agile. So, for example, one of the common problems with Agile, everybody is complaining about too much time is lost on meetings. On the common sprint of 2 weeks, 2 days are, usually are lost on meetings. So that's too much time wasted, if you ask me. So you need to have team, and you need to have people who are fluent in Agile in order for that to work. So you need to train them. It's not something just you can switch on and everybody is Agile now. You need to learn about that. You need to learn how to make yourself efficient and a good team member, and how to use your time wisely. Because at the end of those 2 weeks, you will need to produce something. You will need to show something that you worked on, and that something is working, either a code, either a script, either test scenarios. So it's not easy. It's not for everyone, and it's not common tips, common cure for everyone. Definitely not.
Okay, thank you very much. That was Alexander. Let's give him a big applause.
Thank you.
And now it's time for another break. Let's have a 15 minutes break and see you after that one. Hello, everyone. We'll start in a minute. I have just a few announcements before we begin. So the first thing, Slido. If you want to win a prize at the end of a conference, which will be very cool books, then please remember to add your real first name and last name, because if you don't do that, we will not be able to find you. If your question has won, so if you've seen it on a Slido and it's been asked and selected, but you haven't given your real name, you can still try to fix that and go to the reception and claim that, yeah, this was my question, this was my name, and I won, so I want to book at the end of a conference. Okay, I think we can start. This clock is not very accurate, so yeah. Okay, so our next speaker is Michał Buczko. Michał is working in a New Voice Media, a cloud service company, as a member of a payment card industry. Yes, his everyday job is to work with developers and provide them very good automated test cases for them to test their continuous delivery and integration platform. Michał wants to become a test champion, and he's trying to achieve that via inventing new and diverse methods of testing. He is also very happy to share his knowledge via public speaking. So without any further delay, let's give a big applause to Michał.
Hello, everyone. So there's a slight change in it. So my plan was to be better and better in testing, but turns out that I have got some skills around the business, and I started being a product owner from the last few months. So less technical work, but it proves that mostly the testers are pretty good at understanding the business, and this is one of the possible paths for the future for consideration. The things that I want to talk about is the security scanning with test automation. So maybe I will start with a few questions to you. How many of you are involved in implementing or running automation tests? Okay. How many of you are familiar with Selenium? Pretty good. How many of you are running security scans? Okay, much less. How many of you use Selenium for that security scans? Nobody. Oh, there were some persons at the back. Okay. So basically the main approach that I want to take is to try to convince you to try out the security scanning and to try to use Selenium as a scope that will be then reused by security scanners of your choosing. So at the beginning, a few words about myself. So I'm a quality coach and security tester in New Voice Media, but recently also an active product owner. I joined testing around 8-9 years ago, and I started to work with the card payment industry over 3 years ago. So this is the moment when I switched from straight functional testing to also security scanning and security testing and pen testing and everything that goes with PCI, so payment card compliance documents. And my free time, I'm starting to play with triathlons. So the picture that you can see, it's me running out from the water on one of the competitions. So the agenda for today is, the first thing will be that we'll speak about why security is important and why you should bother running security tests. We'll speak a bit around the test automation, and there will be like an examples of Selenium usage for it. There will be a few words about security scanners. So we will use OWASP ZAP as an example. And I will show you a combination or how to use Selenium with the Zap scanner to have it as a part maybe of your continuous integration environment, or just on single machine as a functional testing or regression testing level. So the first thing, why the security is so important. How many of you use or keep your private life on any online medias that exists? Okay. How many of you got your account hacked on any of those platforms? Okay. So for example, I got my Facebook account hacked by some people from Taiwan. So my account was blocked until I proved to Facebook that Wrocław is my current place of living, and this is the place where I log in from. So how much is stored online? How much people put there? So we've got all those platforms like Twitter, LinkedIn, Facebook, YouTube, Instagram, and we share almost everything. So one of the things that came as an outcome of it, there was a page, "I'm not at home, please rob me." Did any of you heard about it? So basically, when somebody was checking in Facebook, Foursquare, Instagram, in any distant location that he's home, then there was a pin on Google Maps saying that this person is not at home, you can rob him. And they were just using public APIs to do it. So it was people sharing the information, they were just analyzing it, and if it was a distant location, you got like a green light over your home that this person is not at his home. Many people use online banking, online investment platforms that are pretty often attacked. There is e-commerce, so there are online shops. There are many platforms to buy or auction different things. And again, you put your credit card data there. There is like, it's called Software Bank, I believe. So basically, there's a platform method which is not compliant with any PCI standards. It's called Software Bank, and it's a German company. Basically, what they do is they iframe your bank page, and they are able to decrypt and see all the payment data that you are providing, even if it's using HTTPS, because they are signing the HTTPS channel over there. So if you can choose any other payment method rather than Software Bank, please do it. Because basically in the US, it's banned to use that platform. And the PCI DSS is saying that it's not compliant with them. So they should not store or use any payment data. There is the healthcare. So many of us use it to book a visit in a doctor's office. Some of us have like online history of all our illnesses and the other stuff. So this is often used for attacks. And there's Donald Trump. So basically, he is like a person that he's using Twitter very often. And the side effect of that is that his tweets are making an impact on the economy of the US, on the newspapers, who once a week say that there will be a war in North Korea because Trump tweeted something, that he's done with negotiations and the first bomb will finish the negotiations and other stuff. So basically, we came to a moment when there is high influence of the internet, even on the politics. So there is like when Trump was visiting Poland, there was the whole campaign around fake news being stored online and used against some of the organizations or some people. And it started to being a topic of discussion in very different countries about how much the online life can impact on politics that should be internal for every country. The first conclusions is that there's so many code stored online. There's so many people using it. and based even on the voting we've got in a room, you almost all do test automation, but 20% of you are running the security scanning on the products that you work on. But it's pretty easy to do it, but a bit more. So if you want to be convinced more, the easiest way is to use hashtag #infosec on Twitter. So there is also Troy Hunt, who is a security expert, and he's got a page, Have I Been Pwned? And the idea behind it, he's collecting confirmed data breaches or account breaches that are being done. And he made a page when you can check through his database if your account was hacked. So basically, currently, he's got the data from 228 confirmed attacks. And he has almost 4 billion accounts of different people. You can use your login name, email, or whatever you want to, just to check. So based on the InfoSec hashtag, I collected a few Twitter messages from like last few days. So one of the funny things was that there was Iranian hackers who were trying to attack mailboxes for the people in the UK. And it turns out that Theresa May, who is the Prime Minister, was one of those. And her private account was hacked. And they got access to all the emails that she was storing there. Have you all heard about the breaking of the encoding protocol for the wireless networks? So basically, it's based, the crack attack is based on the fundamentals of that encryption. So basically, the algorithm was broken from the beginning, but nobody was taking too much care about it. And suddenly, now it is proven that anybody can break the encryption that you've got in the Wi-Fi, and only half of the producers of the routers applied that they will have a fix for it. And if you've got like a Huawei solution, like Huawei device, then you can throw it away because they are the one of the producers who said that there will be no fix for the firmware that they will be producing. So the next thing is, for example, in the South Africa, there was a data breach that was affecting over 30 million people, and they've got all those data, like names, surnames, addresses, birthdays, everything that it's related. And the latest example from the last few days is in the US, there is a new malware, and the way that they decided to force people to open the attachments in the email is just to say they are the IRS. So it's like, for the US, it's like very trusted organization. Can you hear me? Good. So the 5 biggest, I think it's not working. I don't know if it's working.
Oh, is this one better? We can switch.
Okay, this one is a lot better. So the 5 biggest attacks so far that are confirmed. The first one is the Yahoo. So it's the 2013. At the beginning, Yahoo said that there was like 1,000 or 10,000 accounts that was breached, but every next year they were saying that it's even more. So the latest update from not 2016 as in the slide, but 2017 is that it was almost 4 billion accounts. So every year they are saying that there was more and more. There was the Mirai attack. So this was related with IoT. So there was, in the US, there were cities, they were buying the cameras from China. And it turns out that it was used as a denial of service attack, and it almost turned off all the eastern part of the US from the internet. So Amazon, Google, Twitter, most of the platforms were affected. They arrested some British guy for this, but I don't believe that he was the person to do it, because basically 2 days later, the organization who produced the cameras, they just made a remote firmware upgrade to cover all the tracks. And this guy was arrested based on the information that he was showing the problem in the firmware of that cameras that was reused during that attack, and he was assumed to be the author of the attack. There was the WannaCrypt, breaching a lot of organizations worldwide, so there was a lot of companies which were turning off the internet access from their internal networks, just being afraid to do it. And the funny thing was that WannaCrypt was mostly using any known problems in the operating systems. And the reason why so many organizations was affected was because of not updating the Windows patches frequently enough. And basically there was already some patches for Windows servers to fix the issue, but those companies were using like an old version of the systems. There was the Equifax. So this was a data breach that shown over 150 US citizens' data around the addresses, names, birthdays, social security numbers, and ID numbers. And it was also affecting the Canada and United Kingdom citizens. And the latest one was Petaya. So this was also affecting a lot of public industry organizations. And to the solution, how to use it. So all of you said that you are familiar with the test automation. So most of you are known with the Selenium and the WebDriver. So basically, it's an open source solution that allows you to use UI testing on different web browsers. You can use it from the Selenese code, or you can write your test in Java, .NET, Perl, PHP, or whatever you want to use. It's connected with different operating systems, and you can even use it based on browser stack or any external platform which can run the tests on the slaves that are prepared for you. So in my assumption for this presentation, I assume that you run it locally on your own environments, because then you can combine it with those servers. So this is an example of implementation in Java of the automation in WebDriver. So basically, you can use the JUnit annotation in it. You can run like code, like a part of before testing when you trigger the WebDriver to open a browser. And then you've got like a test part in which you have a function which is running the test steps. And you can close the test after the finishing. So you run an after, for example, function. And a bit more about security scanning. I want to focus more on this because most of you said that you are not running security tests. So my proposition is OWASP-ZAP. So OWASP is an organization which is building a security standards and is cooperating with, for example, PCI organizations. So basically, they built a report which is called OWASP Top 10. That is most common security breaches that you can have in your software or hackers can use to break to your software. There are reports saying that 85% of attacks are being done using the top 10 possibilities that are shown through OWASP. And 98% of those attacks are usually successful. So basically, mostly the reason is that there are reports saying how you can attack software or how you can defend your software. But many companies are just ignoring that, so they are just not having the budget, not having the time to run security scanning. And then they suffer from it. So OWASP-ZAP is basically, they've got the UI in 25 languages, so there is no problem with language behind it. So they are free to use, so there's no problem with the licensing and no additional costs. Basically, you put the ZAP as a proxy between your web browser and between the web application hosted on your servers. and the Zap is intercepting all the movement that you, for example, do during a functional testing or during a regression testing. And then based on the collected information, they can run additional attacks or crawls, so they can collect hidden URLs or whatever you want to, you have on your web server, but you don't put it like a part of your UI. And basically every tool, not only web browser, but every tool that you use for your testing. So if you have like non-UI interface and you try to use some sort of API testing, if that APIs go through HTTP or HTTPS messaging, then you basically can configure the Zap as a proxy. So that allows Zap to collect all the information that you are having. And then you can still run the scans, and you still can have like a security scanning based on it. So it's not only browser related, but integrating Zap with a web browser. For example, Selenium is like the easiest way, and it has the smaller costs that you can have based on either knowledge that you need to do it or the trainings that are needed. So if you are running, as usual, HTTPS, then you have to have like a connection between Zap and a browser that enables Zap to decode the SSL connection and the information pushed over there. So basically you open Zap, you go to tools, you generate your own certificate, and then just upload it in your browser. And this results with, you have to add it that this is a trusted certificate, and this results with you having the ability to just decode HTTPS communication. So basically your security scanning is not only HTTP related, but also HTTPS related. And this opens a whole new window for attack. And it's really just 7 steps to do it. And it's just clicking. It's not coding, not implementing anything in addition. You just import the certificates and everything is there. So basically how Zap looks like. So you've got like a panel on the left side in which you have all the collected get, post messaging. You've got all the attachments that are downloaded and some sort of folder-alike structure of your web applications. You've got decoded request headers on the top. Maybe I will go downstairs for a moment just to... Does it have like a laser or something? Yeah, it works. So basically you have like decoded HTTP headers, and you have the decoded the body of the request. Then you can go through the response, also decode the headers and the body. And there is also ability to rerun any requests, so we can modify it on the fly. You can have like a breakpoints and everything that you do during debugging. So it's not only developers' part that they can do debugging, anybody can do it. And you've got also like alerts tab in which you've got like a list of found vulnerabilities with the levels, so high, medium, low, minor. And then you have the details of every vulnerability that was found with pattern of attack and every details, how to break the software. If you have like CSRF things, then you can generate a sub-page or XSS attacks. It also allows you to generate a page on the fly to just trigger this sort of attack. So it doesn't require you to implement like a new form or any different web applications that should attack or iframe your application to run this sort of attack. These tools run everything for you. You just do a right click and you make like, please generate a CSRF page to try attack on this sub page or this request. And you also can produce a report about those vulnerabilities where you have all the details. So you have the URL, you have the parameter which was used to attack, and what was the attacked pattern, what is the risk description. And basically when you generate those HTML reports, it's pretty easy even for the business people to understand what is the impact, what is the risk, and how. Sometimes it even provides you with an example of implementations how to fix the issue, or it points to a page on OWASP's blogs or any other public web pages like from Microsoft MSDN blogs or whatever, just giving you a proposed solution that can be used and can be solving your issue. And basically, what is the easiest combination? So the easiest combination is to run your regression or functional automated tests from Selenium and just configure the ZAP as a proxy. So I will go again to show you a bit of the details. So this is an example of implementation in Selenium 2.0. So you run a browser, for example, Firefox proxy. You create a new profile, and you set all the HTTP and SSL proxies there with accepting all certificates. So the thing that this will gives you, so basically there are solutions like Foxy Proxy for Firefox, when you can set your proxy, but the problem is if you've got a pop-up windows, those pop-up windows will load with the default configurations instead of the one that you set in Foxy Proxy, because WebDriver, when it's opening, for example, Firefox, it does it in a very specific way, and it doesn't load all the plugins and extensions that you have installed on your default browser instance. So this way of implementing that makes sure that every instance of the browser run through WebDriver will have this set manually. And if you got like a ZAP open as a second application and you've got the same ports defined for ZAP as you have here, then basically you got all the movement that your already implemented automation tests are doing catched through ZAP. And then, for example, you have here implementation from Selenium 3.0. So it also sets up a profile, and this profile has a properties to set manual proxy type, to have correct ports, and then to accept all the certificates. So if that certificates is imported to your browser, then ZAP is also decoding HTTPS movement. And this allows a lot more for them to decode. So basically, thanks to that, you've got the implementation of automated tests that most of you said that you are writing, and you already have. And you can have a ZAP behind it. So basically, ZAP can catch everything that your automated tests are using. And then, as a part of the free solution, like without any additional usage, ZAP is running a passive scan behind it. So most of the trivial attacks that can be like ad hoc run through your web applications is being done as a part of this scanning. And then in addition, you can run an active scan when you've got all the top 20 types of attack, starting from SQL injections, through XSS, through path traversal and other stuff. And you defined how deep it should go through attacking it. And you can then wait. Sometimes it's minutes, sometimes it's hours. It depends on your configuration to get that application attacked. The good thing is that most of those tests are run in a way that it doesn't affect the final server. So usually they don't have the ability to, I don't know, if there's a successful SQL injection, it won't break your database. It will catch it during running the test and just will say, there's a potential SQL injection, this is the pattern of attack, and this is the place in your web application. If you try to check that result, double check it, and run a manual test, then usually you will get a successful SQL injection on your database, and that will be the moment when you break your database. So ZAP usually don't do it, but it might happen that you will broke. So don't try it on pre-production or production servers. Make a separate environment for the security testing, at least for these manual runs. And if you have to do it through some cross-organization used environment, then run only the ZAP scanning, but skip the part when you're manually checking that. This requires an additional environment for you to do it. So in my organization, we had troubles like this. So there was a pen tester who wanted to run manual tests, and he affected the production a little bit. The good thing was that in this region, there were only 2 customers on that server, so it wasn't too bad for them because we were able to fix it in several minutes. But still, ZAP proved that there is an SQL injection on one of the servers, and he was just trying to double check that. So just as a summary, the easiest way how you can have it as a part of your solution for building your software, you can have your build tool. You can have Jenkins or whatever you want to do. You can have the WebDriver as a part of the suite. So in your pipeline, you can have automated tests being run on one of the environments. Those tests will use some sort of web browser and will have ZAP behind it and will attack your web applications. So basically, when you have your automation in your own products, it's just adding one more step to it, and that gives you like a first basic knowledge about how secure your software is. The thing that is like a downside of this proxy-alike applications is that they produce a lot of false positives. So basically, when we started to use it this way, it was like 85% of things that were thrown as a security breaches were false positives. But it's not hard to just double check them if you are not feeling technical enough as a tester to do it, because some of them are just running different types of attacks through a very specific parameters. It's really easy for the developers, based on the report, to know how to debug it or how to double check if the database is secure. So sometimes the ZAP is saying that, for example, your web application allows to do some sort of SQL injection, but sometimes it's the web app who allows it, but there is the database which is blocking that or escaping some different chars or whatever it is. So this is a starting point for you to work with developers. So in our project, we started with the known false positives Confluence page, for example, and we start to store all those false positives, but in more generic description. So then when there was a new tester running the ZAP scans, he was just double checking first with that page if everything is okay. And for example, in my project, when we fixed all the high impact issues and medium impact issues, it was the moment when we were getting a yearly audit through external pen testing, and it was the first audit which didn't result with any security patches required or any findings by the external pen testing organization. So basically, when you handle most of the findings from ZAP, it really allows you to feel pretty secure about the product that you are sharing with the customer or sharing with different external organization. But usually ZAP allows you to feel confident, and even if you show them through the ZAP report that this is the security scans that we were run and there are no high impact problems, no medium impact problems, the customer is usually aware how good the OWASP organization is and how easy they can double check it, double verify it, and that they also can feel a lot secure with your product. If you want to start using this, there is also a OWASP WebGoat product. So this is IIS or Tomcat related application that you can host on your local machine, and you can play with Zap against it. So basically, WebGoat gives you the ability to have an application which has defined security problems, and you can go through the wiki page of the WebGoat, and you can double check how you can attack it and how you can find some of the problems. So you can check it through Zap, and then you can work on your manual skills just to be better prepared. And do we have any questions? You can say it loudly, I can repeat it. Okay, yeah, so there is a scripting part of Zap in which you can write, there's like a command line part of it, so you don't have to do it through the UI. You can trigger even Zap through Jenkins command line operations, and you can start Zap with defined the port that it should be using, and then you can run a command which is saying, please generate the HTML report on this path. And yeah, this is one of the possibilities how you can do it.
Can we switch to the Slido?
Yeah.
Or? Okay, so let's switch to the top questions that were voted. Okay. Is it working?
Yeah.
Great. So, let me read the top question. Have you heard about GDPR, General Data Protection Regulation, which takes the force on the May 2018, and how we can apply secure checks in terms of automation?
Yeah, so basically one of the things is that OWASP should be providing the new top 10 stuff during last year. And they didn't share it, and they didn't share it during this year because of exactly this regulation. So basically, the idea is that probably Zap will be more compliant with it at the beginning of the next year. And there will be a new version of Zap that is straight compliant with the Zap standards. In my own project and my company, we have postponed the idea about thinking on this regulation till the beginning of the next year. One of the reasons is basically I work in a British company, and that British company is taking a part in investigating the Brexit as a whole. And basically this is in May, so if Brexit happens, it might be possible that there will be different standards for the British organization and British products, or not. So it's still, at our side, it's a very urgent topic, but postponed because of the political stuff.
Okay, let me read the next question. Security scanners are producing a lot of false positives. Any tips to reduce this problem when integrating it with CI?
Yeah, so basically you cannot skip that. The problem with the scanners is that they produce a lot of noise and false positives, and our approach was about this Confluence page. So basically, we were trying to move those false positives to a more generic level and then store it over there. And usually Zap, for example, it gives you a grouping mechanism based on the top 10 categories. So it says that there's an SQL injection and there's a list of attacks. And if you just scan through that results and scan through your Confluence page, for example, in our product, when we run monthly regression test with security scanning, and we've got like updates of the PCI applications over there, call center applications, and Microsoft patches. Then just comparing those two reports takes us up to 2 hours, because you don't have to go deeper. If it's like we store it on a category level, and then in addition we've got like a parameter and a pattern of attack. So there's only those 3 informations, and usually they just repeat themselves time after time. So there's a different parameter, the same type of attack on the same URL, for example. And this way you've got like a single row in your Confluence page saying that if there's an SQL injection through, I don't know, time sleep parameter, then this is a false positive. And suddenly it takes out like 100 of messages from your ZAP report, for example. So it's pretty easy to filter that out after you just debug it and double check that this is really a false positive.
Okay, we have time for more questions. So the next question, which of the security scanner tools are from your point of view the most useful for testers, taking into account typical security testing activities?
Yeah, so I would say it's ZAP. Because it's free, because it's standardized, and because that organization, so OWASP, is like the main organization around the security. So they give you the tool, and they provide most of the reports about the top 10s of attack. They update it every few years, and double check it against what happens in the real life. And this way, this is one of the most efficient products. From the usage perspective. So I tried to use Burp Suite, for example. This is like a different solution. So one of the problems with Burp Suite was that the good to use version of the software is having a licensing behind it. So every time you want to use it, you have to buy additional license for every tester. So there is a cost change between the free software and the paid software. And Burp Suite, to be honest, I did like a 3 days dry run through ZAP and Burp Suite. And ZAP, at least from the passive scanning perspective, was pretty straightforward for me. It was just setting up the proxy and getting the results. And Burp Suite was asking me for a lot more configuration, and I was not feeling pretty confident about using it. So I would say it's ZAP.
Okay, moving on to the next question. We still have time. Is it possible to integrate ZAP with environment without GUI, Docker?
So I never tried to integrate with a Docker, but we tried to integrate it with the APIs, which were using HTTP or HTTPS connections and requests. So basically everything that can go through a proxy, if any part of your application or system can have a proxy between the source of the requests and the server endpoint, it can be cached through ZAP. It's just a matter if you can configure a proxy between it.
Next question. What about time and the cost for developing automatic security tests? There are a lot of security issues, i.e. 0 days, that we don't know how to find and protect systems. Pen testers should non-stop writing and launching automatic security tests.
So my idea is that the solution between WebDriver and ZAP gives you the ability to use not security-related automation, but you have your functional-related automation. So basically, you have your all happy path scenario automation scripts. You have your all false or error paths. Everything that you do as a part of your functional testing or regression testing, and then you just put a proxy in the middle. So there is no need for additional implementing automation security tests, because ZAP makes all the functional automation a part of the security scanning. So every step that your automated tests do in your web application is being then reused by ZAP to run a security scans. So I would like to say also that from my perspective, the pen tester is never writing too much automatic security tests. So usually pen tester is building some sort of environment which he used to attack the final application. And usually he's doing that through the manual analysis. So he's either analyzing the binaries that are provided from the server, or he's analyzing the source code of the applications. And from the external pen tests that we had in our applications or internal pen tests, usually this is being made like through a crafting of some sort of security attacks. So I didn't met any pen tester who was writing like automated security tests.
Okay, let's move to the next question. From your experience, how long it takes for Zap to run the passive scan? Is it slow so it can postpone the integration if we add it as a part of automated check for every change?
So the passive scan happens behind the automation itself. So there is no additional overlay through the time to run the passive scan. It all happens in the real time once the requests are being processed by your system. It's the active scan which requires like sometimes even days. So it depends on how deep you define it to attack. So there is like, when you have your tests being configured, you define the scope. There's like options for minimum, medium, maximum, and then you define the depth of attack. And there is like amazing, and there are some levels which when you go through SQL injection on a single web page, it takes 8 hours to scan it. So you need to write like a good combination. So usually Zap asks you to run it through like a medium from the top to the bottom. And one of the good things is when you run an active scan, you have the ability to choose the technology stack. So basically when you have options around the databases or around the language which is used to code, or the platform, where is it hosted, you can choose, is it MySQL, is it SQL Server, is it a DB2 from IBM, is it a PHP application or .NET, does it use XMLs or JSONs or any other. So you can, based on choosing just applicable options from that technology stack, you can reduce the time that it takes to run the active scan. And then again, by lowering some sort of impacts of some tests, you can still lower that. But the passive scanning itself, it happens in a real time, so there is no delay.
Okay, last question. What other scanners do you use in your work?
So currently we use only Zap. And the reason for that was that when we found all the false positives that Zap was producing, and we removed them from the scope, and we only focus on the new findings that go through monthly security scans, we are having like the PCI DSS compliance audit and ISO audit every year. And before starting of that audit, there is a requirement to run full pen tests through third-party organizations. And we stopped having any issues raised by them based only on the results from Zap. So that's why we moved away from any other tools.
Okay, that was our last question. So thank you for your participation in this presentation. That was Michał. Let's give him a big applause.
Thank you very much.
So now it's time for like 15-minute break. The next presentation starts at 3:30.
Raz.
Hello again, everyone. Welcome after short break. Take your seats. This is the last presentation this stream, so make yourself comfortable. Okay, so our last, but definitely not least speaker is Wojtek Anzel. Yes. Wojtek is my colleague from Nokia Krakow. For the last couple of years, he's been living in the magical world of cellular networks, mostly co-processing, you know, RF performance, signaling stuff. He's a very experienced tester. And recently he decided to find out how tester experience can influence creating new product requirements. So he's taking a deeper look at the testability aspect of our deliverables. Some of you may have already seen Wojtek at Eurostar conference in 2015, or maybe you have heard one of his frequent lectures at the AGGUST. Without any further delay, let's give a floor to Wojtek.
Thank you. 1, 2, 3, thank you. When they ask us what do we do in our work, who we are, we usually say that we are testers, or test engineers, or software engineers, or telecommunication engineers, or any kind of engineers, in fact. Usually the second thing that we have to say then is that, no, I will not fix your printer, no, I will not fix your phone for you, but we try to emphasize the fact that we deal with technology, that we create new technological stuff. It means that we are not medicine doctors, economists, not anything else. And also in our it means that we deal with code, with the hardware, things like that. It also means in our subconsciousness that we do not care about any kind of other factors, other things. We do not care about the business. I don't know how to run the business. I'm just an engineer here. We do not care about strategies, product strategy, or selling strategies, those kind of things. And we tend to be proud about it, but the reality is a bit different. And what I've learned in a few years working as a test lead is that if you want to be a good engineer, you actually have to embrace the fact that there will be non-technical factors impacting you, impacting your work. And I'll try to show you some of my ideas, and I'll try to show you my inspirations, how my mind went, and how I learned those conclusions. So by the end of the presentation, I hope you will understand what those factors can be. I won't give you a comprehensive list of those factors, but I'll at least try to show you some good examples. And I hope that you will understand your engineer's role in that word. So there will be four of those inspirations that I have. First one is pretty short. When I was taking my ISTQB training, I was also helping to organize it within my organization. And I was collecting feedback after that from my colleagues, from people that took part in that training. And part of the feedback was, and I was feeling pretty much the same, that, well, I am in this ISTQB training to learn how to find more bugs. I'm not interested in business, in money, in schedules, or the people that will do things. Why are we talking about that? I'm here to learn how to find bugs. I'm a tester, I just want to find bugs. Well, if you spend half a day out of 3 days on a important training, then it means that actually it is an important thing to talk about, and you actually have to accept, approve, and embrace the fact that there will be such factors. Number two is, I want to give an example from within my organization, but before that, I have a question. Which one of you has seen this book? Read a chapter, read it, whole of this book? 1, 2, 3, 4. Okay, not many, so probably not many of you will be interested in the fact that I have something really interesting for you. And what I am about to show you is the first time it will be shown in the public, because there is going to be second edition of this book, and this is the cover of this book. Now, the reason I'm telling you about it is that there's my name on this cover, and there's also Eva's name on this cover. So Eva and myself, or Nokia Kraków, we were invited to put a chapter to this book, and so we did, and we wrote an article or a chapter for this book. And before we sent that to the publishing house, we sent that article internally for a review among our colleague testers, among some of the senior engineers that we thought that their input might be valuable and interesting and important for us. And that feedback was various. So we had some good feedback. We had some feedback regarding the language we write, which was all good points. And we received also some parts of, I would say, bitter kind of feedback. And together with Eva, we were sitting over that one email that we received from one of our colleagues and trying to digest it, trying to think how should we react to that email. And we're going through that points over and over and over again. And in the end, we realized that we are not going to change anything in the article because the person that has sent us those comments, we decided that the person didn't fully understand all of the nuances that we put into the article and didn't hold the broad idea that or the broad perspective that we tried to put into that article. So a conclusion I have drawn personally was that sometimes the best engineers that are in your organization, sometimes the guys that will be the only ones that you will ask to integrate to perform the most difficult integrations, that you will ask to test the most fragile parts of the functionality of your product. Those kinds of people that dig into very dirty details down to earth, they won't have a broad perspective and broad understanding of the product or the strategy, or basically they look down and they tend not to look up. So from this very place, I want to encourage you to always look for the broader perspective and try to understand as many points as possible. In that particular case, it was a discussion about the automation framework we had in our organization. So if you think about it for a moment, so suppose you have automation framework A and automation framework B, and you have to choose a framework for your project to come, or your projects to come in the next few years. So what would you look at to choose an automation framework? First, probably you will look at all the technical factors that are there. So the framework has to be stable, it has to be modular, it has to have reusable libraries, you name it, a lot of factors. But if you go into some discussion with your colleagues, with other people that do automation, read some forums, talk over the coffee at a conference, whatever place it will be, you can hear, for example, a quote like, "It's easy to write in it." And partially, it is a technical factor, because if it's easy, then we're writing good quality of the code. So it's a technical factor in a way. But in a way, it's also a non-technical factor, because if something is easy, then I'm fast at writing test cases in that framework. If I am fast, then I develop more and more test cases in one day, so I can get the product out quickly. And time equals money, basically, so I can earn more for the company in shorter time. So it's kind of non-technical factor already. Another thing you could hear is, for example, I like that syntax, I know how to write in it, I like writing in that language or in that framework. It's cool, it's nice. Partially, it is the same as the previous, but there's, again, more to it. If a person tells you that he, she likes writing in it, it means that he enjoys it. It means that maybe he won't be looking for other jobs in different companies. So if you are a manager, having a group of people knowing framework A, and if you want them to switch to framework B for whatever reason, you got to be aware that there will be a lot of discussion and a lot of talking and a lot of convincing them. Another non-technical factor that can play here is, for example, good support from the community or good support from the vendor. Now, this might be contradictory to some of the technical factors that we have. For example, stability, right? We can say that today the framework is not stable. I was trying to run some test case, the environment crashed. But I reported it to the vendor of the framework, and after one release, after one software upgrade that they did to the framework, my test cases started passing. So it might mean that, you know, if a framework has a good support in the world, then it might be useful for you. Or it might be the framework to choose over the next few years. It might also mean that the community support might, for example, mean that if there is a large group of people developing similar test cases, similar features, maybe you do not have to reinvent the wheel. Maybe you will just change the tires on that wheel and keep going on. In case of our organization, there were actually two different approaches. One was everybody else is or will be using this framework. Why aren't we using this one? So that's one approach, and you see it links with the fact of having good support from the community. And the other one was, we've been always using this one and it worked just perfectly. It's a perfect technical solution. Why do we change? So I don't want to, I don't want to judge any of those approaches. I don't want to tell you which one is better. I just want to show you the fact that, you have a strict technical problem of choosing an automation framework, and from that problem, you go into a very non-technical problem of having a serious conflict within your organization. And that's a thing you actually do not want to achieve, of course. You do not want to have a conflict in your organization. You do not want to you do not want to let frustration on both sides, both from the side of the engineers and from the managers. You do not want that to raise. You end up wasting your time. You end up wasting your energy on basically pointless discussion. The discussion itself maybe not is not pointless, but it's not pointless if both sides are convincing each other. If both sides are camping more and more on their statements and where they are, and they do not communicate and they don't convince each other, then you're basically in a pointless discussion. And this drives the organization in a strange kind of direction. I put question mark here on purpose because again, I don't want to say if it's a good direction or a bad direction. Is it a good direction from technical point of view, from the business point of view? I don't know. I just want to show you the effect of, you know, there's a business decision that there's a technical decision that you try to do, and there's a lot of other factors that influence it. Inspiration number 3 that I have is testing pop culture, I would say. So some of you might have seen this graphic somewhere in the world so far, and probably if you've seen that, you might as well thought that, yeah, I've been there. I think I understand what's happening here. So let me tell you what it actually means. Let me tell you what goes on deep in our minds when we think of a case like this. It might be, for example, oh, not again. I mean, we've been fixing this 10 times this month, and it still doesn't work. Come on, how many more times can we fix that? Or it can mean, why are we releasing this code? It doesn't work. Am I the only one caring about the quality of the product? Are we only chasing deadlines, or are we actually trying to deliver some quality in the software? Or it can mean, for example, listen, Mr. Manager, I don't know if it works. I need to run my 2 weeks extensive regression testing in order to tell you if it works. But what if, going back to the graphic with the cats, what if the delivery day is today, right? So if you set emotions aside for a moment and think about it in non-emotional way, you have your product, you have your delivery line that's in the place where I come from and some people on this room come from. In our case, this delivery line is probably half year long, and it's from just a schedule, it goes to a kind of Gantt chart of death kind of thing that has this big red delivery sign at the end, or P7 or whatever you call the milestone. And as long as you are far off the delivery, everything's fine. You are doing your testing, the developers are doing their code fixes, everyone does what he's paid for, and everything is fine. Until you're 1 day or 1 week from the delivery, and things get really serious. Again, in our world, in the company where I work, in the industry of LTE base stations, which we're trying to deliver, fixing even a minor bug is a pretty complex thing to do. Because if you are testing an LTE base station, in order to test it, you need to have an LTE base station plus a smartphone doing some calls or some operations on it. In your laboratory, you probably have 1,000 of those, so you need some RF cabling or whatever devices will separate the signals from each other. So it's a pretty complex environment. If you are just off the delivery, you're probably running hundreds of megabytes of data for 7 days, for example. You're running a long, extensive test that collects a lot of logs, so you need to store that logs somewhere. You need to analyze those logs. It costs a lot of money, a lot of time. Later, the code analysis happens somewhere between the tester and the developer. Let's say now the developer makes the code fix. Even just putting some new code is a pretty complex thing because there's probably a few hundred of developers committing to one place, so your SVN is not a single laptop somewhere, it's a very big server and very big infrastructure and a lot of facilitation that you need to do. Also, the base station has a lot of components, so before you can build it, you need to wait for all the components to align, to come into one line. It's almost like, you know, planets in solar system coming to one place, and only after they come in one line, you can create a snapshot of that and compile it. And the compilation itself is a cost again. Now imagine that the developer's fix didn't work for whatever the reason is. You go back with the cycle again. So it's a very costly thing to do. If you are in the today is the delivery day scenario, and you're here trying to do the fix and you're unable of that and you're delaying your software, where I come from, if your release is half a year long, the biggest consequence that might happen is that half a year ago, you probably have promised that software to some customer, and that customer is actually waiting for it, and you have a signed contract for it. So at some point, if you are delaying more and more, you end up having contract penalty fees. But if you are, for example, in some kind of software business, startup, mobile applications, whatever, it might happen so that if you delayed your software for 2-4 weeks, whatever the time would be, you might end up with your competition delivering similar software that solved your customer's problem, and you basically end up maybe not selling your product and going out of the business in a way. In any case, your customers might be like, oh, not again. They are late again. How many more times? You can't do any business with those guys. They can't deliver even simple software. So you might lose your trust, brand, your customers. There's a lot of things here. But if you have a bug in system that is so big that you cannot see the product from behind the bug, from behind the fault, and it actually covers everything, the system, the product, the delivery line, everything, you also have a problem. But now the role of the tester is actually to properly say how big the problem is. And mind you, this is not an easy task. It requires a lot of understanding of your product context, of the world that the product exists in, the problems that have to be solved with your software or with your hardware. So the tester's role, and they say it at all the trainings, that you have to fill in this trivial, minor, critical kind of description, plus, as we say in Polish, words plus music. So you have to tell your managers what does the customer have to do in order to see the problem, to find the problem. And this is your role, to, one, be able to tell what it is, two, educate your managers and educate the people that make decisions about the product, whether the problem is actually this huge or is it some kind of minor problem. However frustrating and boring at times it might seem, going to the endless meetings and explaining the same thing 10th time today, unfortunately or fortunately, this is our job. And if we say that this guy is trivial, then we have a problem, and then we do our job badly, and then basically the same things can happen, right? The consequences are exactly the same. So if we try to quantify it in some kind of way, probably you can quantify it with a Pareto distribution. Of course, disregard this chart because I've drawn it in the best engineer's chart drawing tool, which is Microsoft Paint. But basically, the Pareto distribution tells you that 80% of your bugs are found by 20% of your cost. But in the same time, getting the last 20% polish quality of your product will cost you 80% of your testing cost. So there is a saturation to the bugs you will be finding, and there's a fine line in the fine-tuning you want to do with your product. And the bad news for you as a tester is that you do not get to decide on this point. It's fortunately or unfortunately, it will be the managers that will decide about it. And you only get to tell them how good or how bad it is. Now, a couple more considerations. Imagine now for a moment, get back in your mind to your product that you test in your office and think what would happen if your boss told you, okay, we are releasing today. Now, if you have done your test planning correctly, nothing bad will happen, because you should be able to tell your boss, okay, let's release it. As of today, it's the best quality we can have today. It's not the best quality ever that the product gets, but it's the best quality that we can get today. That's a kind of rule of thumb in test planning. Another quote I heard once from actually a manager taking those decisions about the product strategy, was that, our product doesn't actually save lives. It's kind of cherry on top, kind of enhancement to the world the product lives in. So I don't need it to be perfect. I just need it to be good enough. And I need you guys, you R&D guys, to be able to fix the bugs from the field quickly. So again, going back to your product that you have back in the office, how do you shorten your delivery cycle, and how do you shorten your fixing cycle? And now you can imagine why we have been talking about the automation so much, and there was such a huge conflict about the automation. But I have two kind of questions for you that should help you understand how to shorten the delivery cycle. So one is your test environment. So how compatible is your test environment with your customer's environment? If the customer will tell you, I did A, B, C, and D, and the product crashed, are you able to go to the laboratory and do A, B, C, and D, and provide the development with logs, how many times they will need it in order to fix the problem? And number two is, are you able to tell anything about what happened to your product if it crashed in field? Now, since I'm working in requirements now, this guy is pointing at me rather than at you, the testers, but it's a job of us all to work on the product debuggability too. And the last inspiration that I have, it's not exactly related to testing, it's more in the telecom industry. And it's maybe not the most fascinating one that can be, but I think it tells a good story that we can take out something for us. So back in 2012, when Apple was releasing iPhone 5, for whatever the reason was, they decided not to support one of the LTE frequencies. I think it was about LTE 800 frequency, which for operators around the world is pretty an interesting frequency because it gives you a bigger coverage. It's a good kind of frequency to have your network in. And operators worldwide back then were heavily involved in auctions for that particular frequency. If you are a mobile operator, and you want to serve LTE on some frequency, you have to buy it from the government. And 800 megahertz particularly costs much more than, for example, 1800. So in this situation, Apple makes a decision about their software. They actually supported it in hardware, but they didn't support it in software. So based on such, putting such product in field, the operator said, well, if 90% of our subscribers, of our end users are using iPhones, we are backing off from those auctions. So a consequence of software support was that governments of few countries didn't earn few $billion because of Apple's one decision. And if you are now a company like Nokia, Ericsson, or whoever else, you do not get to sell your 800 megahertz product because of that. But there is also a different question that comes to my mind, at least, when you when you see a case like this. First, do we use iPhones in our testing? And the answer is no, but it has its reasons. But the more general answer is, a more general question is, how do your customers use your product? How do you know how exactly the product is used? And again, there are two considerations to it. One, coming back to the test environment, is it able to reproduce the bugs that your customer will give you? That's always number one. Number two, if you are testing some brand new product, if you are testing some kind of proof of concept, something that hasn't been there in the market, and your test environment will be different from the one that will be out in the field, you might end up having tests that make no sense at all. Because in your lab, everything will work just perfectly, and in the real world, it will not work at all. So you need to pay attention to that. And the other side of the scale is if you have a major product. If you have a major product that works in field for years, has a very big deployment, very big scales of deployment, you might end up having test environment that will never reproduce a problem that is out in the field. And if it's so, maybe you do not have to, maybe you should stop supporting that testing at all and focus, for example, on the debuggability side of the product. And the second consideration is how you talk to your customers. So if you are, for example, developing Android application, you probably use the App Store feedback as much as possible. And remember that if you are doing that, you have to take that seriously. You have to consider that seriously, because if your customers will give you feedback again and again, and you will not fix your application accordingly and update it accordingly to what the customers are telling you, in the end, the customers will go away from your application. Number two is talking to customers. And I don't mean only sales representatives talking to the purchase guys and negotiating the prices. I mean engineers talking to engineers, or engineers talking maybe even to the CTO. However stressful it may seem, it actually has been an experience in our organization, and it turns out that it creates good synergies, that it creates, the CTO sees the engineers that actually do a lot of work and put a lot of effort in the product in fixing the problems, and the engineers should be able to, when engineers are hearing the CTO who will tell his stories about what are his problems, what are his use cases, and so on, you should be able to take that input and create a better product with it. And number three is a lot of industry trends, I would call, that basically say, have your customer do your testing for you. It can be gamification, it can be testing coding dojos. There's a number of it. Basically, gamification works in such a way that if you have a customer that will report 10 faults for you, you give him a nice t-shirt. If you have a customer that reports 20 faults for you, you give him a nice Mac or whatever else. There's a lot of such ideas in the industry. It's very popular in some of the software companies. I encourage you to go and search for that ways of testing. So to sum up, if I was to put what the most important non-technical factors will be, those will be, there are three things here. So one is money or time equals money. There's the people, and there's the company itself. So question, how timely can you deliver? How fast can you deliver to the market? Can you release, in weekly cycles, the so-called MVPs, so minimum viable products, right? This balance between cost of implementation and the quality of your product. All of those questions that relate to the money and to the time. Regarding to people, I think it's pretty obvious that the people that work on the project have to know their stuff about the technology. They have to be skilled enough to do it, but they also need to be enjoying the work and enjoying their colleagues. And the company itself is, again, a lot of non-monetizable factors, non-monetizable things that are out there. So the customers, the trust you have built, the brand, and for example, the product strategy. Now, again, like to sum up, I would like to encourage you to, familiarize with all those. Try to set yourself in some kind of context of that, and I want you to realize the fact that as engineers, you have to be aware of those. You have to be aware of the context you and your product are in, and the more you know and the more you learn about the context, the better the engineer you will be. Thank you.
Thank you very much, Wojtek. Let's switch to the Slido questions. I hope it's working.
It's not working on this one, so I have to go down.
Yes, it's working. Okay. So the first question is, do you think that test engineers should raise their objections loudly when managers want to release poor quality products, or just get used to it, as in the end it's management decision based on wider picture of business case?
Yes, definitely speak out loudly. Yes, that's what I told you. That your role is to loudly speak out what you think the product quality is, why is it so bad, and put up all the details of that idea. The more details you put to that discussion, the better coverage you have yourself in your consciousness, right? If after such communication the managers still say that, okay, we want to release poor quality, then it's not your fault anymore. But if you did not speak out, then it's your fault too. Did this answer the question?
Okay, moving on to the next question. How are you calculating cost of testing quality in overall SDLC cost, and how to show benefits of testing to senior stakeholders?
Whoa, that's a complex one. Well, I don't know how to calculate the overall cost. Well, the cost consists of a lot of things, and I was trying to put as much as possible in that one slide when I was showing how do you fix a bug. It's, you know, whatever, the definition of the metrics can be very different. I don't have a context of a particular organization to tell you how should you calculate your cost. It can be, you know, calculated in money or in time you take to deliver a product. It's a tough question.
Okay, moving on to the last question on the Slido. Is missing documentation a bug that should be raised by testers?
Now, mind you, I am working in specification right now. So I can dig my own grave right now. But, well, is it, so maybe rephrase, is it the problem actually that you have a documentation? If it is a problem, then you probably should go to your system engineer and ask him for that specification. But if you know what you have to do without that specification, maybe there's no need for it. Again, it depends on the context, and that's a message I was trying to put here in this presentation. Maybe I didn't make my point well enough. Testing basically is we say that testing is a context activity or context-driven activity. So it all will be depending on the context. If you are testing an LTE-based station, you probably need some specification to know how it works. But if you are testing an Android application that, you know, draws funny cats, maybe there's less documentation that you need to be written, and maybe it's not a problem that you don't have that documentation. And maybe, you know, the only communication is that I don't like the application because it's hard to use it, but it's not something you can put in the documentation sometimes.
Okay, I can see a follow-up question. What about user documentation? I changed the, but it seems to fit the previous one. So what about user documentation?
Like the end user documentation.
I guess use cases, right?
Well, okay, so apparently it seems that in that context, it's something that is needed and is missing. So probably it is a bug, it is a fault. I'm just not sure if it's a fault of your product or rather a fault of your organization.
Okay, moving to the next question. Any idea how integration event helps people to be better engineers, testers? Okay, not sure how it is.
Not sure how does it relate to
the topic of a presentation.
To the topic, but I will answer this one. How does this conference make you a better tester? And that's the end of my response.
Okay, do we have any other questions from Slido? Okay, we still have time for one more question. So if there is anyone in the audience who was afraid to use Slido and would like to ask a question via microphone, just wave your hands.
If no, then I'm around here. So
yeah, Wojtek's around, you can ask him. Okay, thank you very much for your participation, and let's have a big applause for Wojtek. That concludes our stream software testing methodologies. Thank you for your participation. There is a coffee break ahead of us, so enjoy. I would like to ask you to leave the room fairly quickly because we need to prepare it for the big keynote provided by Isabel Evans. Thank you very much. One more thing, please collect your belongings. We need to clear the room fully, so nothing can stay here. Thanks.